Hi everyone. So today we're going to talk about segment addition postulate. So first, the segment addition postulate right here. They're always going to like kind of draw a picture for you, and you need to be able to understand how to put that to paper. So if Q is between P and R, that means Q has to be in the middle if it's between them. I'm going to put P here and R here. I usually just go alphabetically with that. So P comes before R in the alphabet, so I'll put it first. They're telling us right here that PQ, PQ plus QR equals this whole thing, PR. So all this is a part plus a part equals the whole thing. Now, we don't know, guys, if these are equivalent parts. It's not like they're saying Q is a midpoint. If they said Q is a midpoint, then I know that these two parts are equivalent. Similar, look right here. You can tell like AB is not equal to BC just by the way it's drawn, but you also need to be able to prove it mathematically. You need to be able to figure out what they are. So I'm going to go ahead to a problem over here. It tells me to label AB as 11. So this right here is 11. BC is 4. Then they want me to answer what is AC. So just looking at this picture, this is a part, and AC is a whole. So if I add up the two parts, I'm going to get the whole. So I can do 11 plus 4 equals the whole thing, 15, which is AC. So if I wanted to write this out as segments, I would be saying that this part AB plus this part BC equals the whole thing AC. And then I just rewrote that here. AB is 11, BC is 4, so it equals 15. That's my AC. Another example of this over here, if AL is 26, that's the whole thing. Now they're going to give me a part. So now I'm going to have a part and a whole. So it's a little different. So TL is 16. I'm missing AT. They want me to find AT. Now, if I know a whole and then I know a part, that means if I add this other part, these two parts should still equal the whole thing. So just looking at this, a lot of you can just answer this already, that we would do 26 minus 16 to get this part. That would give me 10. That's equal to AT. Okay, a lot of you will just be able to answer that right off the bat. Algebraically, this is the way it would look. Then we would subtract 16, and we get 10 equals X or AT. Okay. Now it's going to get a little more beefy, as I like to call it. We now have some algebra coming in here, and we got to draw and label our picture on our own. So the picture we're trying to draw is H between G and I. So I'm going to draw a segment GI, and I'm going to put an H between. Remember, these pictures are not drawn to scale. Those kind of look equivalent. Just because I drew it that way doesn't mean it is. GH is 2x plus 2. HI is 3 times x minus 1. So we are going to have to distribute that. I'm just going to do it right now. If I distribute that, I get 3x minus 3. 3 times x, and then 3 times negative 1. And then this whole thing, GI, so this is a part, this is a part, and this is my whole. GI is 29. So I have to do a part plus a part equals the whole. So my part is 2x plus 2. My second part is 3x minus 3. And my last part, my whole is 29. So I've now written my equation. I did step 2, and now I'm going to solve it. 3x and 2x can combine to be 5x, and then I can combine 2 minus 3. That gives me negative 1. And then I'm going to add 1 to both sides to get 5x equals 30. And then if I divide by 5 on both sides, I get x equals 6. Now there's still one more part to this problem. They want me to plug in x to find the missing segments. You'll notice up here they said find x, find GH, and find HI. So a lot of these problems have multi-part answers. They're asking you to do multiple things. So you've got to pay attention, make sure you answer all the questions. If you were in school and you did this on paper and you finished right here, that was only answering one of 3 questions. So you would lose points. So we already solved x is 6. GH though is 2x plus 2. We got that from the info in the beginning. Now that I know that x is 6, I can go ahead and plug that in and find my GH. So that's 12 plus 2. So that means that GH is 14. Now there's 2 ways you can find HI now. You can look up here and see that HI is 3 times x minus 1. And you can go ahead and plug in that 6 again. 3 times 5 is 15. The other way you can do it is, okay, I know my whole is 29. You can just do this logically. My whole is 29. I found one of the parts to be 14. So let's just subtract 29 minus 14 gives me 15. So you can do that logically or you can do it out mathematically. It's totally up to you. All right, so now I want to move on to the back, or the last part of this note sheet. This is a really challenging problem. You will probably not see one of these on a test or a quiz, but it is important that we go over them. So there's a lot going on in this picture. The first thing I do notice, though, is that I do have a hole. I have a lot of parts here, and the crazy thing about the parts is that they overlap. That's what makes this picture so confusing. But right here from E to H, I do have a hole. So I'm definitely going to have my hole over here, 12x plus 18. And I'm going to try to find another way to find a hole. Now, if you look here, I have 2 pens and they overlap. Okay. If I take away one cap, and just ignore the tip of the pencil here. If I take away that cap, then I'm left with a full piece, right? So this is now on top of this, I'm left with a full piece. They're just not on each other. So if I put this over it, I'm left with it. If I put the cap back on, I'm left with 2 pieces that are overlapping. I need to take one away. So if I look at this picture, I have this full segment and another full segment, and they overlap right here in the middle at FG. So I like to call, this is the overlap, and I like to label that FG as my overlap. So the way I can set this equal is if I want to say this side is equal to this side, I need another hole over here. But the way I'm going to write my hole is I'm going to write it as EG plus FH. So that's this piece plus this piece. And then I'm going to take away my overlap. So I'm adding those and then I'm subtracting that overlap FG. Now, that's writing it in segment terms. I'm going to do it mathematically now. So EG is 5x plus 27. And I'm going to add to that 25, which is my FH. Wrong letter. FH. And then I'm going to subtract my overlap of FG, 3x plus 19. And now I got a lot of math to do on this side, so I'm going to keep this side the same, bring it down. I'm going to simplify what's in these parentheses so I can add 27 and 25 to get 52. And now I'm going to distribute this negative. So I'll get negative 3x and negative 19. Okay. Now I'm going to start to simplify what I have on this side so I can combine 5x and negative 3x. This side's going to stay the same. 5x minus 3x gives me 2x, and 52 minus 19 is going to give me 33. Now I can start to solve for x here. I'm going to subtract 2x. I get 10x plus 18 equals 33. Then I'm going to subtract 18 on both sides. I get 10x equals 15. My last step is to divide by 10, and I get that x is 1.5. I've now solved for x. This is a lot of work, and it's a lot of visual representation here, and you really have to be able to see this visually, that this is the same as this whole piece minus the overlap. So all I did was say, I know this segment plus this segment is equal to this one if I just take away the part that they overlap. So if this wasn't here, they'd be the same. I'd have this plus this, which would give me a whole. Now, they did, though, ask me for x and fg. I've already found x. I still have to find fg. So fg is labeled in the picture as 3x plus 19. So I'm just going to plug in that 1.5. 3 times 1.5 gives me 4.5 plus 19. That gives me 23.5. And that's fg. So like I said, this problem is a challenge. So sometimes we may throw it at you in classwork to see if you can handle it, but it won't be on a test or a quiz. Okay? All right, guys, have a great day, and I wish you good luck on your quiz today. Can't turn this thing off.